Class, Dr. Selby here again with video 2 on how to name and write formulas for ionic compounds. We're going to step this up a little bit with naming ionic compounds that contain transition metal elements that can form variable charges. In the last video, we focused on naming ionic compounds that contained predictable ions from the valence rule, such as the ones I just circled there. 1A, 2A, and 3A. In this video, we're going to focus on the cations containing transition metal elements or group 4A elements, most of which can form cations with variable charges, so not predictable. There's some exceptions to this rule, and that is that zinc always forms a +2, and silver always forms a +1, and cadmium always forms a +2. The rest of the transition metals and the group 4A metals can form more than one charge, and so we need more information in naming them. So the names of transition metal cations that have variable charge use a Roman numeral in parentheses after the name of the metal cation, and that's to identify the charge. Some examples, not an all-exclusive list, is chromium. Here we're showing here chromium 2 and chromium 3. Chromium with a +2 charge. In its name, you put that 2 in parentheses as a Roman numeral. For chromium 3, you put a 3 in parentheses as a Roman numeral, and so on. This again is not all inclusive. I'm going to start out a little bit differently here in writing the formulas from the name, because writing the names from the formulas takes more work. So let's start easy and then go to more difficult scenarios. So on the last slide, I showed that whatever the symbol here given indicates the charge on that metal cation. So I'm going to just write, like in the last video, write the formula of that cation above those names to start. So I have here iron 3, Fe +3. Here I have manganese 4, so that's Mn, and that Roman numeral 4 says it has a +4 charge. Tin 4 oxide, so we have tin Sn, and this means it has a +4 charge. And then here we have lead 2 sulfide, so lead is Pb, and this 2 means it has a +2 charge. And then let's go on to the anions. This is the same as in the other video. These are predictable. These anions are predictable here. So chlorine, which is in 7A, will gain 1 valence electron to form the chloride ion. So it has a -1 charge. Nitride, which is in 5A, will gain 3 electrons to form the nitride anion. So this is N3-. Oxide is in 6A, so 6 valence electrons to have an octet. It'll gain 2 electrons and have a -2 charge to form oxide. And then sulfide is in 6A, and the symbol is S, and it gains 2 valence electrons to be like the closest noble gas, and will have a -2 charge. So now, just like in the last video, we're going to write these for charge balance. And here I have iron with a +3 and chloride with a -1. Lowest common multiple is 3. So I want a total of +3 from the cation and a total of -3 from the anion. I'm going to do some work here. We have Fe +3, one of those, and then to balance that charge, we need 3 fluoride anions. So this is FeCl3. In manganese nitride, lowest common multiple between +4 and -3 is 12. And so to achieve that, we need a +12 from the cations total and a -12 from the anions total. So to get 12, 4 times 3 is 12. So we're going to need 3 Mn +4. And then we're going to need 4 N nitrides. So the formula is going to be Mn 3N4. By the way, I don't think that exists, but it's an example of how to write the formula if it did exist. For the next one, we have here a total of +4, here a total of -2. So we need 2 oxides to equal a total of -4 to balance that +4 charge on the tin. So we'll have Sn +4, one of those, and then 2 oxide anions. And so a total of +4 coming from the cations and -4 coming from the anions. And so the formula is just SnO2. And then in lead-2 sulfide, we have +2 here, we have a -2 here. So we get charge balance with a 1-to-1 ratio. And we have PBS. And that's how we're going to write formulas from the name. Let's go on to something a little more complicated. That is naming ionic compounds with variable charge metals. The reason this is a little more complicated is we have to figure out the charge on the cations, on the metals, because we have to include their charge in the name. So how do I do this? I'm going to write this, this has iron, this has copper, this has chromium, and this has lead. And they can all have variable charge. So I'm thinking, and this 2 means that we have 2 of those iron, whatever charge they have. This means no subscript means we have 1 copper, this means we have 1 chromium, and this means we have 1 lead. So I'm going to write this 2 iron. I don't know the charge. I have to figure that out. This is just 1 copper. Don't know the charge. Have to figure it out. Chromium. Again, don't know that charge. And then lead. Don't know the charge. But how can I figure out the charge? I can figure out the charge from the anions. And I know that the overall formula has to have charge balance. So I have here, I have 3 of these sulfide anions. And so this here is a total charge of -6, which means I need a total charge on the cations of +6. Well, if the charge on that iron cation is +3, +3 times 2 equals +6. So these are each +3. So this would be iron sulfide. Next one, I have my anion is fluoride, and there's only one of them. And fluorine is in 7A. To be fluoride, it gains 1 valence electron and has -1 charge. So to balance that total of a -1 charge coming from the anion, we're going to need a total of a +1 charge coming from the cation, which means this is just a +1. So this is copper 1 fluoride. Onto the next compound here. From the anions, we know that we have 3 oxide anions and oxygens in 6A. It'll gain 2 valence electrons to form oxide, so each will have a -2 charge. That tells us that the total charge coming from the anions is -6. So the total charge coming from the cations has to be +6. And we only have 1 of them, so this has to be a +6. So this is chromium 6 oxide. In the last example, here we have 2 sulfide anions. So we have 2 sulfide. The charge on each sulfur is going to be -2. Each sulfide is -2 because sulfur is in 6A and it gains 2 valence electrons to form sulfide. So this is -2. So our total charge here is -4. And we only have 1 of these. So that total charge has to be +4. So the charge on the lead is 4. So this is lead 4 sulfide. That concludes this video. I hope it was helpful in naming ionic compounds with variable charge metals and writing their formulas. Thank you and have a great day. I'm going to make another video on including polyatomic ions.